Hi, my name is Oleksandr Adamov. I teach malware analysis at the universities. One university in Sweden, Black Institute of Technology, and another one, my home university, Kharkiv National University of Radio Electronics in Ukraine. I've been teaching malware analysis for 15 years. I created the course and I've been updating this course. And now, of course, time has come to update it so it has some information and knowledge how to use large language models, because this is a trend nowadays in the industry and specifically in cybersecurity. And I'd like to invite you to my two-day training at BlackHat 2025 in December in London. We are going to introduce this first version of the course. And briefly, what we are going to learn, we start with just the intro, how AI impacts cybersecurity and where we can use AI technologies in this area. And then we traditionally jump to static analysis. We start with refresher, and then we will learn how to use LLM to parse PE headers, resource action certificates, and so on, collect this information. Next, interesting session where we will analyze .NET malware and malicious documents, documents with embedded malicious scripts, VBA scripts. And we will also try to use LLMs to deobfuscate the code, obfuscated code. And finally, at the end of the day one, we'll apply LLM to detect, so it can detect malicious payload of malware. Using information from static code analysis, for example, PE header, certificates, resources, import address table, and so on. And of course, we will try to create Yara rules to detect these samples. Day two will be devoted to, the first part of the day will be devoted to dynamic analysis. Then we will try to use AI classic machine learning algorithms as well as Gen AI to perform attribution, APT attribution. This is one of my favorite topics. So we will use case study of Whispergate, and we will use different approaches how to make attribution. And we will see the results. We can compare how easy it is to do with LLM versus using classic machine learning algorithms. Session 8 and session 9 will be devoted to development of skills how to build AI agent. So the final goal of this training that we will be able to create malware lab with AI assistant that will be responsible for using different tools and performing specific actions, specific tasks, and will help malware analyst to aggregate this information, extract this information, and generate the final report. So the overall goal is, of course, to speed up the process and make malware analysis fun. Because I know that my students, they struggle learning assembler. So when I show them malware in assembler language, then they get scared, and that's not really approach I want to use. And so you can feel a flavor of using LLM for malware analysis. I want to show you a small demo. And this will be about SolarWinds backdoor embedded into SolarWinds Sorian platform. This is an attack that was conducted by Russian intelligence service against SolarWinds. They managed to inject the backdoor into one of the DLLs. This DLL was distributed to the customers, and many, like more than 1,000 organizations were affected, including Microsoft and FireEye. And we will take a look at this DLL and try to identify the backdoor where the backdoor is located, and try to start analysis and ask question LLM about something what is not clear for us. So this is basically how the supply chain attack looks like. So attackers inject backdoor, the DLL is then distributed, backdoor activates, then they get this information and connects to command and control server to deliver information about the target, infected target, and of course receive commands on what to do next. And of course, when the backdoor activates, there is a mechanism that checks, okay, if this backdoor is activated in sandbox or in malware analysis environment, or it runs in original environment. And we will take a look at this code. So basically, the code is executed in refresh internal method. You can find it in the article published by Microsoft. And actually, this thread is actually the backdoor. It is located in Orion Improvement Business Layer .initialize. As you can see, the attacker, they try to mimic naming convention used by the developers in this DLL. So it's not really easy to find out, okay, where the backdoor's code or where the original code. So here is the function where the backdoor starts, and the first check, it gets hash of the current process. So this is the process that runs this DLL. The name of the process is lowercase, and is compared, the hash, calculated hash in this function is compared to some static constant. Okay, if we go to the hash, we see the code that seems to be a hash function. But which one? That's the question. And let's ask our LLM. I'm going to use GitHub Copilot, so I'm going to copy the code. And I also interested what this constant hash stands for which string, for which process name. So I'm gonna copy it also to my temporary file. Okay, now I'm ready to ask my agent, my LLM, about this function. So which hash function is it? And then I can provide the function without this constant. So let's see if our LLM can help us to identify the type of the hash function. Well, technically, you can try to Google different hash functions and then compare this code to available hash functions. But, well, why should we spend our time on such a routine job? Okay, here we have the answer. It's a 64-bit FNV1A hash. The initial value, the loop does XOR, then multiply, which is FNV1A. The function applies a non-standard final step. It returns num XOR and some constant. So this is an extra XOR, which actually modified the original FNV1A 64-bit hash function. So it's a custom hash function. So this is this is a trick that often used by attackers when they create the custom encryption algorithms, hash functions. So it's really hard to analyze and decode. But now we know that there is some extra And this extra modifies already existing hash algorithms. Okay, then the question, okay, what is the string that this hash stands for? If we go back to the code, then we get the current process. Then the question, okay, this is a SolarWinds Orion Core Business Layer.dll. And okay, what is the name of the process that executes this DLL? Let's ask our LLM agent. What is the name of the process that loads SolarWinds Core Business Layer.dll? Okay, it tries to find the hash, but this seems to be a wrong way for. And then it search for SolarWinds references. And yes, so we have it extracts the information about the process name. So the process name is SolarWinds business layer host.exe. And of course, we need to make it lowercase. And yes, we can ask to calculate the hash for the string, right? Calculate the hash. Calculate the hash using the given hash function for the string, and then we provide the string. And we need to lowercase. Yeah, actually, we can basically to the string make it lowercase first. So it, as we can see, it generates a short Python script, which is asked to execute. Yes, please. And so we have different values, and they do not actually fit our hash value. When then we can go to our code and check how this process name is obtained. And when we get current process, get process ID. So let's go back. Yeah, there is a process name. So how this process name is, so there is a get method. How it's obtained. So here I can see there is a code responsible for changing extension, and with the get file, when the method get file name gets the module name, which is this process name, then it replaces extension with null. So basically, it simply removes the extension from the string and calculate the hash for this string only. So let's change our request and calculate the hash for this lowercase string. And then we can compare the result with the constant that is available in the code. Yes, please execute. And here we have, okay, this is a decimal representation, unsigned long. So this is the same hash constant that we can see in the code. So, well, it's just a small piece of analysis, small part of the analysis, but you can see how easy and how useful LLM agents can be. So they can identify type of the functions. They can help you to calculate some of the values, and you can even ask LLM to provide some additional information that you are not aware of. For example, what is the process name that executes this DLL? Well, you can Google and find it on the internet, or you can install this product and see this process. But I think it's really much easier just to use LLM to find answers for your questions. Thank you for your attention, and I hope to see you in London. Bye bye.